Hi all. Welcome to the very interesting topic that is the greatest common divisor, GCD. This is a common problem in the number theory. So when A and B are two numbers and the GCD of two numbers is the largest number that divides evenly into both A and B. For example, the GCD of 60 and 24 is 12. Suppose if there are no common factors except one, and hence and they can be called as relatively prime numbers. So the GCD of 8 and 15 are 1. So for the example 8 and 15, they both don't have common factors and hence the GCD is 1. So these two numbers are relatively prime to each other. Suppose for these two numbers we do it in the traditional method. If those two numbers are really big, then we have to depend upon some other method for finding out the GCD of those two numbers. And here comes an easy method called as the Euclid algorithm, which helps us to complete the GCD of any two numbers. So this is the algorithm. I'll explain to you in the next slide, which will be easier more than this. As per the divisibility algorithm, A is equal to B into Q1 plus R1. So let's take GCD of any two numbers A and B. That's what represented as here. And then it is written as so when you perform the division operation, you will get a quotient and a remainder. That's what Q and R. And now in the next step, what happens? The B1, that is the second number. So the first one, A is called as the dividend and B is the divisor. And the divisor of the previous step becomes the A value, the dividend of the next step. And as per the arrow mark, the remainder of the previous step becomes the divisor of the next step. So this is the concept. This will be repeated until you get the remainder as 0. This is the formula. This is the concept. So now let us do one example. Let us consider the following example. Find out the GCD of 1160718174 and 316 258 250. So very interesting question. If you get a question like this, then we need to find the GCD of these two numbers, such a big numbers. So by traditional method, it is impossible to do it. It will take a lot of time. So let's do it in the using Euclid's algorithm. Let's do it using Euclid algorithm. So let's take the first number as the A value and the second number as the B value. And we know our equation, which is A is equal to Q1 into B plus R1. So this can be written as the formula has to be repeated. So the quotient, you'll be taking it as for the next A value, and the remainder you'll be taking for the next dividend. Okay. So it will be represented in this way. So A is equal to 60718174 is equal to quotient. So the first step, you will be dividing the two numbers, and when you divide the quotient, you are getting it as 3. So 3 into 31625 250 plus the remainder is 2119434 and 24. So this, when you divide these two numbers, you're getting this as quotient and this as your remainder. So now we have to take the numbers. So we have to take the b value as the next. The b value becomes, sorry, this is b value. So the next line becomes b equal to next quotient, and then the remainder r1 becomes here plus the new remainder r2. Okay, so let us write this. This goes here. That becomes the a value 61258250 is equal to, and the remainder you should, the previous remainder you should write here. So 211943424. So what you have to do now, divide these two numbers and you will get a quotient. Quotient you have to put it here and remainder you have to put it here. So the quotient is 1. You can do it with a calculator. The quotient is this and the remainder is 1043148 2 and 6. Okay. The next, so this becomes the new a value and this becomes the new r value. Okay, that is, this will go there and this will come here. This is how it will happen. So 211943424 is equal to the quotient into the remainder will come here, previous remainder will come here, 434826 plus the new remainder will come here, and the quotient is 2 and the new remainder is 3313772. Okay, this is how, since we have a remainder now, we need to proceed until we get the remainder as 0. That's the concept. So now let us look into the next step. So what we have to do, the next step is this comes here and this comes here. So we have to divide these two numbers, 104 and this one. So the remainder, the quotient, we will get as 31 and then the remainder will get us 1587894. So next step, what we have to do, so this is 3313772. This will go there and we have to divide these two numbers, write the remind quotient here, 2 into, and then this will come here plus the remainder is 137984. Okay, and the next step, this number will go here and we'll get this number here. We should be taking the 1587894. Divide these two numbers and take the quotient and the remainder. So the quotient is 11 and the remainder is, so this is this number. So the remainder is 700 and 70. And the next step is this will go there and this will come here plus. So dividing these two numbers, we'll get the quotient as 1 and the remainder as 67914. Okay. Next again, repeat the same thing. Divide these two numbers. So we'll get the quotient as 1 and then remainder as 2156. So this will come here. So in the next step, so this will go here, and then into this will come here. So 2 1 5 6 plus, so when you divide these two numbers, so this will go here. Now when you divide these two numbers, you will get the quotient as 31 and the remainder is 1078. So the next step is 2156 will go here and 1078 will come here. When you divide these two, the quotient is 2 and the remainder will be 0. At this step, once you get the remainder as 0, you can stop at this point and the divisor is the final answer. So the GCD of these two numbers is 1078. This is how you should perform the GCD of any two numbers using Euclid algorithm. Even the very big numbers, we have easily done it through this algorithm. So A equal to Q1, A is equal to Q1 plus B. That's the basic thing you should know. So we should always remember the Euclid algorithm like A equal to Q1 into B plus R1. So A and B are the two given numbers. So GCD of A and B, that's what the given question. And now what we have to do in next step, we are dividing A and B, so we will get a quotient and a remainder. And in the next step, what will happen? This B will come this side. So the equation becomes B is equal to, and this place becomes the previous remainder. Okay. Now we have to divide the B and the R1 value so that we will get the new quotient and new remainder. This is the concept. And then next what happens? So this R1 will go here. So this is R1 equal to, and this R2 will come here. Okay. So we'll be dividing R1 and R2, R1 by R2, so that we will get the new quotient and new remainder. Okay. So one more step we will write. The equation is the R2 has to go here. So R2 becomes the new A value and then R3 becomes the new B value. When you divide R2 by R3, we will get the new quotient Q4 and the remainder R4. This should be continued. Okay, when we have to stop, the algorithm stopping criteria is when the remainder, this remainder is 0. If R4 is 0, then stop the algorithm. In this case, R3 is the GCD. So stop the algorithm when you get the remainder as 0 and your divisor is the GCD of the given two elements. So this is how the Euclid algorithm works. Stay tuned for more examples.